Welcome, Dave.
I always try to land exactly on time, not 2 minutes early. just finishing a call. So it's one thing to the next every day. That's sort of the way that things go.
Yeah. Well, everyone, this is Dave Campbell. As I mentioned a little bit before, he studied art at Cabrillo and then moved to engineering. He transferred to Cal Poly and graduated in 2007 with a degree in civil engineering and in particular in structural engineering. And he's going to talk to us about the work that he does. I feel like you're an architectural firm, at an architectural firm now, and the kinds of projects he works on and how he's parlayed all of his background into the work he does currently. So welcome, Dave. And I think you're in Hawaii, right? It's like 8:15 in the morning.
That's not 9:15. It'll be in a couple of weeks when you guys go on daylight savings time. Well, we don't, right? It doesn't move over here, and so that's when it gets really early. And my standing 9 a.m. Pacific office call, because we've got offices in Chicago and San Francisco, and so we have a 9 a.m. Pacific time standing meeting every morning with the offices. So far that's been a little early. I'm not a super early riser by nature. I wish I was, but so it's the 7 a.m. and then in a couple of weeks it's moving to 6 a.m. and I'm like, oh, this is gonna be rough.
Well, or you could finish the call and go hit the waves.
Yeah, there's that, right? Is that you're up early enough to kind of get out and go for a quick surf.
Exactly. Well, welcome. And we have our new class of Engineering 5 students who are really excited to hear about the work you're doing.
Okay, let me just share my screen here and we'll get started. So I've got a couple of projects that I'll kind of walk through just to try to explain, what my background is. And as I'm going through this, I have a tendency to sort of gab away. And so, feel free, any of you, to jump in or I don't know if you've given them specific instructions on how to interact, but
But I think you can type your question, a couple options, type your question into the chat, or like Dave said, if you come across a pause, just, feel free to jump in. I think those are great options.
Cool. Great. So are you guys seeing my screen? There's a couple of images up of a few projects here.
Yeah, we are.
Okay, perfect. So as you just heard, my background is a little bit circuitous. I studied art originally, graphic design specifically, and then switched to engineering. Went through the program at Cabrillo, and then I went to Cal Poly for my undergrad to kind of finish the undergrad. Worked in a structural design firm for a couple of years. Then I worked in structural forensics for a few years, which is really just looking at how buildings fail. It's, sounds a little more romantic than it is. And then I did my master's in architecture at Berkeley. And I currently I'm a project manager for a firm that does both architecture and structural engineering. And there are a lot of firms that do this, but we're a little unique in the sense that we specifically do them together. Like we're always looking at how do we use structure to enhance and express our architecture, and then similarly, how does our architecture sort of express the structural intent of these projects? And one way to kind of think about this is that we're really interested in intuitive structures, or things that work on intuitive principles. And so to explain this, maybe as an example, I'd like you guys to consider a slice of pizza, which sounds like an odd pivot, but basically the idea with pizza is like if you just pick up the end of the pizza, like you pick up the back of the crust, if it's a good thin crust pizza, it's just going to sort of droop down, right? It's challenging to eat. And so what we do naturally is we sort of fold it a little bit, we kind of bend it, and then that allows the tip of the pizza to stay straight out. We use the same principle with paper airplanes, and there's a structural principle at work here called virtual depth, But really what this means is that effectively the pizza, when we fold it, is acting as if it's the full depth of the fold from the lowest point to the highest point, rather than just the actual physical thickness of the pizza. So we've used this at my firm. We use this principle actually all the time, and any folded plate structure, which is not super uncommon kind of structure, uses the same principle. So this is one of the projects that was on that intro slide. This is actually a stair in a San Francisco Victorian house, and basically what the principle is here. So this is all eighth. It's actually a little less than eighth. It's yeah. Not quite 16th inch, but a little thinner than 1/8 inch steel. So very, very thin steel, and it's all perforated, which is why you can kind of partially see through here. And so that alone, if you stand on it, super flexible, right? It's just going to kind of bend and buckle and even dent under a person's weight. But when you start to fold those things, you get substantial stiffness out of this. And so we can make a 2-story high stair out of conceptually a single folded plate, folded piece of steel. And that's what you see is on the right is this diagram of, conceptually the whole thing is basically made out of one piece, and then we just fold it into this 3-dimensional structure. And the reason why this was so important, not just because it's awesome, but also because like with these Victorian remodels, they're very narrow houses. And so when we were designing this, we were working to cut through the house as much as possible and really open up the space. And so there's this huge glass wall kind of behind the camera on this right image. And the last thing we wanted to do is then go put a solid staircase, right through the middle of this. All the work that we've just done would have been sort of negated by the stair. And so the use of this perforated stair allows that to not only have some life and movement through the space where we can kind of see that, that red color winding its way up through the house, but it also allows light all the way, deep into the house. And so we're looking, again, it's like a basic structural principle. How do we accomplish something spectacular in a sort of simple way? Like it's an easy to understand way, I think. And then what are the spatial implications of this? This is really the design ethos of my firm and my work kind of over the last 7 or 8 years. So the next project I wanted to look at kind of builds on this a little bit, or this idea. And so this was an idea of a flat packed adjustable pavilion. So you could basically break this down and you ship it in a box, and then you could pop it up into these little shade structures. And the exploration here is kind of related to that idea of folding. It's connected to an idea, oops, sorry about that. It's connected to an idea of bending. And so if you think about like a sheet or a pad of paper, if we have a force in the middle of this, the whole thing sort of flexes, right? It deflects. But if we take that same material and we turn it the other way, and we try to push in that middle, and things fall out of our notepad, it's very stiff, very strong. So the orientation of material is really, really important in terms of how strong it is particularly in a bending orientation. And so what we did, you can see these little curved patterns here. Basically what we were looking at was, could we locally control the depth of the material in order to create specific types of bends? So you take a flat square element, and if you sort of have a low spot, that creates a soft hinge or a very kind of locally weak area. And then as you flex that, it naturally bends the shape into whatever form you're trying to make it take on. And so with this, basically with the same system, but just changing the location of these curves, we create hinges in different spots. And the set of bottom diagrams there is showing a number of different orientations and iterations of the same system, right? Just slightly different CNC milled curves. So moving on to maybe something a little bit larger. This is a bridge that we just had finished. It's actually almost a year old now in terms of being opened in March of last year. And this is in Ohio, so it's just outside of Columbus. It's a pedestrian bridge. It connects. What you're seeing in the background here is the old town, which is kind of the old commercial and tourist center of this town, to this new development that's on the other side of the bridge here, or sorry, on the other side of the river here. And so this bridge it's super unique. But the main thing I wanted to focus on here is, again, trying to look at. It looks very complicated, and there are some very complicated structural problems here. But what allows us to sort of approach these is from very simple principles, very basic principles. So when we look at that central tower, for example, the cable that supports the whole bridge has a huge downward force, right? And what we're looking at is like when you split that force to create space between this, and this is what we do with houses, right? With a roof, it's what we do with all buildings to a certain extent. Is we take a vertical force and we orient it into either two angles, or we use an arch, or we use some other means of transferring that vertical force to a vertical force somewhere else. So here we split that vertical force into two diagonal forces. Which creates a thrust, right? It's a little unbalanced. And so the tendency would be for that element to just sort of kick out and flatten. And so we tied it back together again. And then that creates two smaller vertical forces that go down to the ground. And then using a principle called stress shaping, we basically smooth out that process, which makes it a little bit more efficient. And that eventually gives us the form of this eye of the needle tower. And this third image here that you can see, that's the actual stress gradients for how forces flow through this tower. And the tie, which is sort of missing in the third image there. But this structural tie, which is connecting across here, we use the bridge deck for that. So basically the bridge flies through the center of the tower and actually holds the tower together, resolves that thrust. Let's see.
Could you talk a little bit about like how you're creating these images, the software programs you're using?
Yeah, that's a great question. So we work really heavily in a program called Rhino, which is a three-dimensional modeling program. Rhino is for architects, it's sort of the gold standard. It allows us almost total flexibility in the geometry without putting too many limitations on us. So there's the other kind of major programs that you guys have maybe heard of is Revit on one end, which is a building information modeling software that Autodesk, who makes AutoCAD, produces. So you've got Revit, you have a program like Rhino, and then you have programs like SketchUp. And that's sort of a gradient in terms of what they're used for. So SketchUp is an extruder, which means that it is very, very fast to model sort of traditional kind of rectilinear forms. It can also do curves and very complicated things, but you have to be a little bit more advanced to do that. Rhino was actually originally designed for boat building. And that's one of the reasons why it handles these very curvaceous forms really well. And then Revit is much more of a documentation program. So Revit knows that you're modeling a building, which means that, it's really hard for our work. One of the reasons why we don't use Revit is that it is expecting a wall to be vertical like a wall. And a lot of times our walls are not exactly vertical. Our doors aren't exactly door shaped, and our windows might be partially on a wall side and partially on the roof. And so sometimes we'll use Revit at the very end of a project just for documentation, but for design and for a lot of these diagrams that I've been showing, we use Rhino. And then Rhino has a bunch of plugins that basically add functionality for structural engineering and computational design and this sort of thing.
Thank you.
Sure. And actually, this is probably a good moment since we're talking about software. This is one of the renderings of the bridge. And so this was produced with a plugin for Rhino called V-Ray, which is a sort of a standard renderer in the industry. But then a whole lot of work in Photoshop as well. So when we're trying to, it's an interesting thing because it's like, we're not just making pretty pictures for the sake of making pretty pictures. We're spending $22 million to build this bridge. And one of the things that people want to know when they're spending that kind of money, whether it's the city who's actually heading it or the public that they answer to, is what are we getting for this money? And so we end up spending a lot of time and energy representing our projects in ways that people can understand. And some of that's trying to explain the structural forces and the efficiency, but a lot of times it's trying to just capture what is this space going to be like? You know, what is the experience of being on this bridge going to be like, for example? And then this, you know, these are just fun. So this is the construction sequence, basically one image every day of them constructing the tower. They actually modified some highway bridge forms with custom CNC molded foam inserts. That's how they cast the central tower. And then you can see they're pushing all the bridge sections in. They've got these little stands down below that support it temporarily, and they're moving, you know, rock around to kind of provide the working surface. There's the bridge, and then right a couple of steps back, you saw the stands disappear. So they put the cable in here. That's not a very good color for this image. Let me try a different color. So they put the suspension cable in, and then what you basically do is you have these support points which have the bridge a little higher than where it's supposed to sit. It's basically jacked up on top of these. You connect all the cables, the hanger cables they're called, and then you tension them to the proper tension, and then you basically unload the jacks, and so you transfer the load from the support points slowly onto the cable structure. You try to do that very evenly, and there's a whole sort of subset of engineering which is literally just how do you actually build these things. It's one thing to say this is how it's designed when it's finished, but there's also what's called construction sequencing or staging, where we really have to kind of go through, you know, the every step along the way and make sure that, you know, things are not going to fail as we're going along.
Dave, we have a question in the chat. How much liberty do you have when designing structures like this bridge? Are there a lot of limitations?
Yeah, that's a great question. The short answer is yes, there are tremendous amount of limitations for anything that you do. And in many ways, the larger the scale, the more, well, maybe a better way to say it is that's not exactly accurate. So with things that are in the public eye, let's say this is, my firm sort of specializes in civic projects. So even though we do a lot of private work as well, a lot of the stuff that we really pour our time and energy into are projects like this, bridges and parks and that sort of thing. So the public has a say in it, and then there's also the actual owner, which is usually a municipality or the city in this case. And then there are a huge number of stakeholders, various property owners, leaders within the community, who also have some degree of input or say on these projects. And so, you know, our job as the engineer is to sort of solve the problem. Our job as the architect is really to make sure that the solution is something that everybody understands, is on board with, and is excited about. And you're never going to have a project like this where, actually this one has been very surprising. I have not seen any negative feedback. Because anytime you spend money on anything, there's always somebody or some small or maybe large subset of the community that goes, that's not what we should be spending money on. And I think that's a valid argument, but you always get, when you work in the public sector, you always will be sort of struggling with this issue of, you know, how it's funded with public funds. And so the public has a say in how it's constructed. And some people just don't think that pedestrian connections are a good thing to spend money on. People don't want mass transit. Some people do. Some people want bike paths. Some people don't, right? And so as the designers, we having to negotiate these different stakeholders and try to figure out how do we get as many people on board as possible, and then always kind of in mind that you're never going to make 100% of the people happy. And if you do, you probably did something wrong, you know. So you're probably sacrificing something really important. That might be a good sort of transition into this park project that we have in South Carolina. So we have a number of different pieces here. We have this observation tower, which you can see in the foreground, and then a pedestrian bridge and a visitor center and sort of concert venue and a bunch of picnic shelters and a number of other ancillary structures in this project. And this is this really, in my mind, is one of the more important projects we've done the last few years. This is Greenville, South Carolina, and this used to be a segregated park. So the background here on the far side of the river, so it's maybe not super clear where the river is. The river is this riparian zone right here where the bridge goes across. And basically this park was the white park and this park was the black park. And they literally used the river to separate these things. And so for us, as we were approaching, the different elements in the project, one of the things we were primarily concerned with is how do we build this connection between the two sides of these parks to really try to symbolize both practically and symbolically, but how do we really evoke this idea of unity and kind of sort of including all the communities in this area as the city moves forward, which is really important to the city. So this was one of these projects where we got a lot of positive feedback on different things that were being published as we were going through the design, and we got a lot of negative feedback too. We got a lot of reactions of we shouldn't be spending this much money on a park. We should be spending it on whatever, right? Whatever that citizen's primary concern was. And in the end, because we sort of hit, and this is just bad timing, this is something you guys are going to have to deal with in your careers as well, is you sometimes will, especially in civic projects, you spend a tremendous amount of time and energy and effort designing and working through these things. And then something outside of everyone's control, like the pandemic hits and cripples the tourist industry in this city, which this park was almost entirely funded. The public portion of the funds were, which is about 60% of the overall budget for the park, was funded essentially by a bed tax and restaurant tax in the city. And so all of a sudden it went from being something where, the city is booming and everyone's like, yeah, this is a great thing to, well, not everyone, but there was good consensus. People really wanted it to being where the city council was basically like, we cannot spend $40 million on this park of money, that came from restaurants and hotels when those restaurants and hotels are closing and really struggling, which I agree with. I think that they made the right call, but it's pretty heartbreaking because a lot of this stuff got cut or reduced or postponed. And so the one of the positive things for me is that this observation tower, which is one of my favorite pieces of this park, and we worked really hard to kind of develop this, but that observation tower, they just phased it out of the project rather than canceling it, and they're seeking private funding. So basically we're in the process now of trying to find enough manufacturers and corporations in the area who are willing to put forward the money to actually build this thing. And it's going pretty well. I think we'll be able to start construction about maybe a year and a half. It's a challenge when you're working in the civic realm, for sure.
So is the park not built? Is that what you're saying? It was designed and then not built at all?
Yeah. Well, so no, they are building. So they're still building the park, but basically a significant number of the pieces. And if I just go back a couple of slides, so basically the bridge got redesigned. So they're still having a bridge here, but all of our architectural and sort of structural expression got axed. So it's just a very simple kind of crossover now. This visitor center got cut basically in half. So and I don't have any detailed images of this for this quick presentation here, but the band shell area that's cut. The visitor center got much more simplified. They changed a lot of the actual landscape architecture details have been reduced or simplified. So they're still doing the park. It'll still be a good asset for the community, but it's the sort of scope and vision had to be scaled back substantially just because of the reality of the moment that we're in.
Wow.
Things go sometimes. So, I wanted to show a couple of quick images, and I know I'm kind of running out of time here. I wanted to leave a little bit of time for questions, but just really quickly. So I wanted to show this one to sort of encourage you guys as you're considering what sort of segment of engineering you move into and how you develop in your professional careers and experiences, to not forget about understanding, in engineering, we often call this like back of the envelope calculations. Basically, it's the conceptual sort of proof. So you're not doing the full detailed calcs. You can do simplified versions, which get you most of the way there. And in a similar way, being able to hand sketch and sort of understand how something gets assembled this is really how our work gets done. And then the three-dimensional model that's on the right, that's the proof of it, right? That's sort of this sketch is 78 or 75 or 80% of the design. All the calculations and the aesthetic of it are all being set kind of off of this detail. And then once we have that, which we can produce and iterate on very, very quickly, we can make these models to sort of validate and define our concepts. And so here again, it's on the left is a series of sketches for what these different, ideas were. And then the final design shown on the right. And then I'll just blow through this one because it's kind of fun. This is really the point of this. This is a concrete, kind of crazy concrete structure. And this is one of these like direct integration of structural design and architecture, where the vision for the project and the way that we modeled it, we actually had to write additional software in order to prove this. So this is the stress of this concrete structure, but with every material, there are different building codes you have to abide by. And concrete has some very specific characteristics because there's the concrete, but there's also steel. So it's a composite material. And so basically for every one of these individual elements, we're using what are called interaction diagrams to figure out exactly how much reinforcing needs to go in them. And from that, we mapped that back onto the model. So instead of just showing the stress, we're actually showing, where the reinforcing is required, the high points and low points of reinforcing. And then we had an algorithm that smoothed that out so that we can basically, get this from something where structurally we have the understanding of the problem, but then we have to kind of march that all the way through into something that is buildable, that can actually be constructed. This is kind of a fun project because this is all very digitally controlled. So this curve here for the dome was all CNC'd, so it could be as precise as possible. And then all of the formwork for the concrete is also every element was modeled, oriented, and CNC milled, and then eventually installed. As the formwork for these guys. And because this is such a novel project, we also had to do full-scale mock-ups, which is something that you guys will probably have to do at some point in your careers as well. This is under construction now, so it's a little bit further advanced from what we're seeing. All right,
cool.
Took it right up to the my time limit here.
That's okay. Do we have any questions for Dave about the work he's doing or his educational path?
I have a question.
Go ahead.
First, I want to say thank you for the presentation. I'm really interested in the work you're doing, and I'm a fan. But I wanted to know a little bit about, I was wondering if you can speak on your trajectory from transitioning from art to structural engineering, and what the setting was for you to decide that transition, and what the timeline was for you to actually like go from one to the other.
Yeah, it's a great question, Luis. So you always have different sort of things that precipitate movement if you're kind of shifting career goals or educational goals. And for me, there's a lot of things happening in my life that sort of made me take a moment and say like, okay, well, what do I actually want to be doing for the next, even if it's the next 5 to 10 years, as opposed to like, what am I doing right now, right? And I think up until that point, when I was studying art, I was really thinking like, what do I want to be doing right now? And then I started to think like, well, what do I want to be doing in 5 years or 10 years? And some personal stuff, but also just some, as you get into a career in graphic design, you sort of realize, and I think this is true in probably most professions, but you sort of realize like what your daily looks like as opposed to what you thought it might look like when you were in school. And that sort of put a question in my mind of like, do I want to be doing this in 10 or 15 years? And the answer was like, well, in some form, yeah, that'd be great, but it didn't feel like there was enough meat to grab onto for me. It wasn't challenging enough. There didn't seem to be enough direct, impact on the physical world, on other people, engineering had always been something that I had some background in. I always made stuff growing up. I worked on cars. I had some, interests in how things work and figuring those things out. And so, at this transition point, I was like, well, maybe I'll take, and actually I didn't take engineering 5. I'm not even sure if 5 was there at the time. Probably was. This is a while ago. So the program was a little less sophisticated than it is now. And but so I took a class with Joanne, who I don't know if you guys have met or had classes.
Oh yeah, with she's co-teaching this class, so they know her.
Great. Okay, great. So you guys are well acquainted with Joanne, and I was just like, this woman's awesome. Like she's like making me super excited about the way that we're solving problems. And I actually distinctly remember doing in the material science class. Looking at candy and trying to like understand the material properties, like the tensile strength and the ductility of like Laffy Taffy. And I was like, this is great. I love this, And so that really sort of set me on that trajectory of trying to understand more specifically how things work, and being able to not just understand them intuitively as I was sort of driving at, but also be able to take that next step and back them up with, with an actual theoretical, proof of those intuitive ideas. Does that answer your question? I think I sort of just rambled there a little bit.
I actually studied art for 4 years, and I'm going into engineering. So, and I'm looking at architecture stuff. Architectural stuff, so structural, civil, environmental stuff.
One thing I would recommend if you haven't started looking into this already, but there is at Cal Poly and K-State and a few other programs, there's a major called architectural engineering, which is it's focused primarily on structural. And so like my undergraduate degree is in civil with an emphasis in structure. So I took a lot of structures classes, but I also took wastewater and transportation and a bunch of other classes, which were super interesting, but they're not something I use every day. And so it's one of those things where if I was going to go back and do it over again, I probably would have done architectural engineering because it would have been more of a direct exposure to, you actually do some design studios, you work with architects. It's housed within, at Cal Poly, it's housed within the College of Architecture, not the College of Engineering. So you get really good at the above ground structures, but you're also looking at it from the perspective of the architect. So it's an engineering degree, but you have a much stronger connection with the design side.
Dave, we have another question in the chat, and I know Phaedra has joined us as well. The question is how tricky is it to balance structures that can be designed versus what a construction team can build?
Oh, yeah. If you ever figure out the answer to this question, please let me know. So to try to keep it relatively short, this is a huge challenge, and one of the things that we always are doing is working our way through the construction process as we're designing things. But it's also you try to get to know people who are building these things and get to know a location. One of the biggest challenges for us is because we work all over the world. Not only every industry, but every like specific location is different. So what is totally buildable, and we have 3 fabricators who could design or who could fabricate something in San Francisco. We go to South Carolina and people are like, whoa, we don't know how to build this. So the level of documentation is different. One of the ways we try to mitigate that is by meeting very early with fabricators whenever we can and try to get them on board with the design idea, and also get their input in like where they're going, well, you guys think we can do it this way, but we can't. Could we do it this way instead? Or that would be really hard, we think, and so as you guys are progressing in your careers, maybe I'll just leave with this thought, is make sure that you are listening to contractors. Make sure you're listening to the people who are building these projects and asking them questions and trying to get feedback from them. For me, like something like half of the wood framing details that I use regularly, I've gotten from carpenters, not from other engineers. So definitely make sure that you understand that this can be a very fruitful partnership. it can be very trying at times. You have different motivations and it can be stressful. But, you know, at the end of the day, you guys are all on the same team. You're trying to complete something, you know, that everybody makes money on, and the project is finished successfully and the client is happy and it's a beautiful, you know, precise work. And as long as you can kind of keep that mentality, even in those meetings where you feel like you're enemies with the people who are building these things, that's something I keep coming back to and try to remind myself of, especially after these sort of frustrating days. So yeah, it is a moving target all the time. The technology is always changing, and the locations have a huge impact on what builders are comfortable with.
Cool. Thank you so much, Dave. This was so great. And if they have any more questions, I can forward them on to you.
Yeah, absolutely.
All right, go hit the waves.
All right, thanks, guys. It was nice chatting with you.
All right, thank you.